All right, awesome. Hi, everyone. My name is Derek Lomibao, and I'm here today to talk about creating conversational AI with AWS Lex. So first of all, who am I? I'm a senior developer at AutoNation, and I work on the customer engagement platform team. We are doing all sorts of cool stuff. I've had the opportunity to work on creating sentiment analysis for customer engagement, building chatbots like I'm going to show you how to do now so that we can answer customer questions. And I've gotten to do stuff like video processing work so that we can take videos that we share with the customers and show them the repair progress of their cars. I have a master's degree in computer science from Iona College, and I enjoy being creative in all aspects of life and work. So who is AutoNation? Most people don't know about AutoNation, but we're America's largest network of auto dealers. We sell thousands of cars every day, and we repair and service millions of vehicles every year. And you would generally not think of AutoNation as much of a tech company, but we have hundreds of IT professionals working at AutoNation. We cover all sorts of disciplines. The scale at which we operate within the auto industry is so large that we need to build a lot of custom solutions to help our associates and help our customers. So our stack is varied. We've got both AWS and Azure, Java, C#, and you can read the list. But we are hiring for both internships and full-time. The link's here, but I'll also be sharing that link at the end as well. So what exactly is conversational AI? It's essentially referring to a set of technologies which users can use to interact in a human-like manner with a machine. Essentially, we can leverage machine learning for natural language processing and natural language understanding to recognize speech, text, and human intent, and then respond in a way that essentially mimics the way a human would respond. Most people are familiar with Alexa and Siri, virtual assistants that are using conversational AI. And then there's a lot of things going on now, such as what we're using at AutoNation to create chatbots to help aid in customer service. So how does Lex come into the picture? Amazon Lex is essentially using the same technology that Amazon Alexa is to make it easy to build and deploy these conversational AI systems. It provides speech recognition out of the box. It only requires minimal training data to recognize what the user is trying to do, also known as their intent. And it's free to get started using AWS free tier. Note, a lot of tutorials out there for Lex reference Lex v1. That's the old one, obviously, and not Lex v2. They're not backwards compatible with each other. This specific talk is for the new one, Lex v2. So there's a lot of challenges with building these kind of conversational AI systems. So we need to identify languages that the user is using. With Lex v2, it introduced multi-language support. We need to figure out what the user is hoping to accomplish. And that is provided by intents and utterance training. We need to pull in data to gather the necessary information from the user to fulfill their requests. Amazon Lex provides easy ways to create something known as slots. And we need to use the user-provided information to fulfill the request, whether it's looking up some data or completing some action where we're making some sort of API or database call. And they provide code hooks for that using AWS Lambdas. So as I mentioned, there's this concept of intents. So in this picture, you can see 3 different conversations. And essentially, a customer in all of them is trying to find a vehicle to buy. But the way that they say it to let us know that that's what they're trying to do can be extremely different. So in the first one, I'm interested in buying a black SUV. In the second one, I want a gray Toyota. Third one, I want a red Toyota truck. So all of these are basically saying to the Lex bot, hey, we want to find some sort of vehicle you have. And you'll notice where I mentioned things like color and the type of vehicle and the make of the vehicle, those are variable. So they have the concept of slots. So in this case, this first one, we have a color, which is black, and SUV, which is the vehicle type. Here we have, we were looking for a gray Toyota, and here a red Toyota truck. So if we need to look things up based on a variety of things, Lex makes it easy to say, hey, we need certain information in order to fulfill the user's request. And it will provide output that can kind of help guide the user along in making those requests. So let me go ahead and pull up the Lex console. Let's see. All right. So here is Amazon Lex's console. And I'm just going to go ahead and open up this Java Lambda bot that I created and kind of give you a sense of what's going on in here. So as I mentioned before, Lex supports multiple languages. In this case, I'm only using US English. But the interaction I'm showing up in the corner here is this vehicle inventory search. So all of these user inputs are basically saying, we want to find a vehicle. Within vehicle inventory search, we have the intent name, and I just provided a little description so that we know what we're trying to do. There's this thing called contexts, which are optional. That's more of an advanced topic. We don't need to talk about that right now. But essentially, there's this concept of utterances, and that allows us to take these intents, which are the goal the user wants to fulfill, and train the model to be able to recognize that that's what the user is actually trying to do. So we can train the model using these sample utterances. In this case, I want to buy a car. I want to buy a type of car, which is like a Toyota or a Lexus. What kind of cars do you have? All of these things are used to train the model of what we're trying to do, but it's not limited to any of these. So here, let's see. If I were to say something like, give me a truck, right? None of that is trained on this model, but it will be able to detect that we're trying to search for a vehicle still. Since I didn't provide any information of what the make of the vehicle is, we have this concept of slots. And it has this prompt of what make a vehicle so that we can automatically ask the user to tell us what make they care about in order to be able to fulfill their intent. So if I say Lexus, so in this case, it looked in our inventory and there was no Lexus trucks available, which isn't surprising. But if I had said, give me a Toyota truck, or give me a Lexus SUV, it would be able to detect that. So you can make these slots either required or not required. And then there's also this concept of a slot type, which is essentially just kind of a classification of what this slot represents. So it can be one of these custom slots that I've created, and I'll show you how to do that. Or it can be any number of built-in slot types from Amazon. So they've got some basic ones to help out of the box. The ones I find most useful are the date and the phone number and time. Those are very, very useful. So if I go to these slot types, you can see I created a whole bunch of them, or not a whole bunch, but a few. And if I go ahead and open one of these up, you can see that I created the slot type vehicle type. And then we can choose between either restricting the slot to a specific set of values, or we can say to Lex, hey, there's a lot of possibilities. I want to be able to just provide a couple of examples and you figure out the rest. So the vehicle type, we know that there's only a limited number of vehicles that we want to consider. So we have car, SUV, and truck. And Lex allows us to create synonyms for it so that whenever a user says something like sedan or coupe, Lex will know to map that to a car. If I show you color, for example, This one, there's many different types of colors. There's no way I have the patience to train the model on every single possibility of color. So I just said expand values. And that will allow us to use just a little bit of example data to work as training data. So because I use this, then the user could say something like, I want a magenta vehicle, and we could try to look for that automatically. So let me go back here. And then one thing you'll notice is that within the utterances, I'm allowed to provide these slots that I mentioned directly in the user's request. So if we say, what's your inventory of make and vehicle type, we can automatically detect these within the utterance that the user is requesting and populate those slots automatically without having to prompt the user for these values itself. There's also the potential for creating prompts for confirmation. These are pretty useful if you are, say, booking an appointment or making some sort of transaction that you really want to make sure that the user is sure that that's kind of the settings that they want to use. So if they were, booking an appointment, you would want to ensure that they provided the date and time that they actually cared about, so that they don't accidentally make a mistake. And then closing responses. This allows us to just automatically reply when all of the required slots are filled. And this is useful for really basic bots, but it's not what you really are going to generally be using if you have kind of some code hooks, which are provided here. And basically, Amazon Lex allows you to create Lambda functions, which essentially just run an arbitrary piece of code for you in the cloud without you having to worry about provisioning a server and kind of standing everything up and maintaining it or scaling it if you have a lot of volume. I'll go more into the code hooks when I do the live demo of setting up one of these bots. Let's see. So like I mentioned, AWS Lambda allows you to invoke a piece of code without having to worry about provisioning it. It supports Java, Go, PowerShell, Node, C#, Python, and Ruby. But it has the ability to support literally any language with their runtime API. And it can be triggered either on every single Lex interaction. So if you wanted to, say, validate something, some of the input that the user provided, you can check every single time, or you can do it, trigger it only when all the required slots are populated and ready, which is known as fulfillment. So you can use AWS Lambdas to connect your LexBot to databases or APIs. And it also gives you access to session attributes, which can allow you to share the context of your interaction across multiple back and forth rounds of interaction. So now I'm going to show you start to finish how to create one of these Lex bots. And in this scenario, I just created, I'm going to show you how to create a simple pizza text adventure mini game sort of thing. Basically, You're going to choose a chopping. You're going to choose a crust. And then you can cook the pizza over a number of turns. This is essentially allowing us to showcase every major feature of Lex and integrating with a Lambda and using that session state that I mentioned. So let me get back to the console. All right, so the journey for creating a bot essentially starts on the main Lex console. And as you can see, there's a create bot button. So let's go ahead and create that. We're going to start with a blank bot. AWS provides examples if you want to get started as well. And then all of my examples, there's a link at the end to access all the code for that if you want to play around with it yourself. So we're going to call this bot make, or let's call it pizza shop bot. And we want to make pizzas. The IAM permissions, it's generally just a good idea to create a role with basic Amazon Lex permissions. If you've already done this in the past, you can just select an existing role. And then Children's Online Privacy Protection Act, if it's subject to working with children, you would say yes, but I'm going to click no because there's nothing sensitive about this. Idle session timeout, you can just leave this stuff alone. But essentially, this kind of tells Lex how long you want your bot to remember its session information. So if a user disappears for 10 hours and then comes back, you don't want it to think that they're in the middle of a conversation normally. So I'm just going to go ahead and click next. And then we can start adding languages to bots. So every bot has at least one language. I'm just going to stick to English US. Lex does support both voice and text. I'm just going to show text in this one. But if you wanted to, it has the option to choose what voice the bot will speak in. And then there's this intent classification confidence score threshold. This is saying how confident does the bot need to be in order to say for certain that this is what the user wanted to do. And kind of decreasing this means that it will be able to detect an intent even if it's a little unsure of itself. And if you have a higher value, it kind of filters out utterances that a user is saying that are very wildly off. But in general, it's fine to leave this at the default value unless you are getting bad results. So within this new intent, okay, so we just created this pizza bot shop, and I don't know why I created this intent, but let's go back. By default, there is a fallback intent, which will default when nothing else is matched. But we're going to create a new one, and we're going to call it make pizza because that's what we want to do. We want a user to say something and we want to be able to make a pizza. That's what their goal is. So we can train that. Oh, sorry. Okay, so that's the intent. But if we actually go and take a look at my scenario, what we really want to do first is set up these slots that we care about. So if I go over here to slot types, we're going to want to go ahead and add a slot type. So we're going to add a blank slot type. And in this case, the first one is going to be topping, because pizzas have toppings. We can go ahead and expand the values. And so we can say pepperoni. We can say mushroom. We can say cheese. And we'll just leave that as our training data for now for the toppings type. So I'll go ahead and save that. And then go back to slots, add a slot type. So we'll call this one crust. And we want to be able to support just a limited set of crusts. So in this case, we'll have thin crust, which could also be thin crust, as a synonym. We can support pan pizzas, and we can support deep dish. So then go ahead and save that. Finally, we want to have the type as kind of a confirmation of whether or not we want to continue our interaction, because we're doing this in turns, essentially. So I'm going to call this one go on. And we're going to restrict that as well. So I'm going to say the first one is continue. And the second one is end. So a synonym for go on is, or continue is go on. Or I could say things like, I want to continue waiting, something like that. And then a synonym for end could be, I want to stop. Okay, now that we have all our slots set up, I can go back to my intent, make pizza. And I can start saying, or adding my slots in. So we have a slot name of topping, which is going to be of the topping type. What topping do you want? And then I can go ahead and add my crust, which is crust. And what kind of crust do you want? Thin, pan, or deep dish? Okay, and then finally, we have our final slot. Let me just double check what I named this before. Okay. So I called this one wait or stop. And this is our go on slot type. And note that I don't want this one to be required because on the first interaction, we don't need this yet. Okay, so I've set up my slots. And then I want to check on this code hook, use a Lambda function for fulfillment. All right, save that. I'm going to start building it. And then while that's building, oh, what happened? Oh, sorry. I forgot to add utterances. All right, so I want pizza, make a pie. I want a so this is going to be like if I want to say something like I want a thin crust pepperoni, or I say something like this, I could say I want a thin crust pepperoni pizza. All right, now I can save this and build. So I didn't train it on very much, but that should get us started. And then if we go to the Lambda, okay, so this is the AWS Lambda console. I'm going to go ahead and create a new function, author it from scratch. We'll call this Pizza Live. As a function name, you can call it whatever you want. This one, just for brevity, I'm going to use Python, but I can show you the code for both Python and Java. Or if you use something else, we can work together and I can help on that as well. Just going to leave it as the default permissions. And I'm going to create this function. Okay, so with AWS Lambda, if you're using something like Python or Node JS, it allows you to have just this built-in code editor to kind of make things easy. So I have some sample code that I'm just going to go ahead and paste in. For now, I can show you the exact details in a minute, but I'm going to go ahead and deploy that. Changes have been deployed. All right, and then now we can go back to the pizza bot. And then if we go to the aliases, this is essentially the kind of logical name of the bot so that you can have multiple different versions, but then and switch them back and forth. But right now we just have a default alias, which is the testbot alias. If I click on that and then click on languages, it allows me to provide what Lambda function we want this alias to be using. So I just created Pizza Live, and you can choose what version of it as well. So I can go ahead and save that. And if we go back to the bot, the intents, if I go ahead and test this now, let's go ahead and clear this up. So I want a pan, let's see, thin crust cheese pizza. Okay, so I want a thin crust cheese pizza. It recognized that. And then we have this continue or stop that I mentioned on the go on. So it should take 2 turns. If I were to stop now, the pizza is not cooked yet. So your cheese pizza is uncooked and you get food poisoning and might die. If I were to go ahead and say, make a cheese pizza, and then say pan pizza this time, and I were to continue instead of stopping, you have 1 turn. I'm going to go ahead and continue again, just because I want a cooked pizza. So there's 0 turns left. So let's go ahead and stop now. And my cheese pizza is cooked to perfection and it tastes delicious. So let's take a look at what's going on here. Within the Lambda itself. And essentially what happens is the Lambda gets invoked initially. And we want to detect what intent we're caring about for this Lambda. So we get the intent name from the request. And if it matches make pizza, we'll go ahead and run this method process pizza. So this is where the heart of the code is. Essentially, I start by getting the session attributes and then pull in all my slot information from the request. I provided a bunch of helper methods. So if you're creating your own, you can kind of leverage some of these helper methods to make it easy for you. And so if both the topping and the crust slots have been populated, we can begin trying to cook it. And so we want to leverage these session attributes so we can keep track of if it's being cooked and how many turns there are left in order to complete our pizza. So I go ahead and set that the cooking status is started in the session attributes, and I create another attribute called rounds left to specify how many rounds we want this to run for still. And just note, session attributes are always string values. So if you want to do things like JSON as a session attribute, you'll just have to stringify it. And then we want to return a message back to Lex. So in this case, I'm providing plain text, and I'm just returning your topping crust pizza is getting started, and it should take 2 turns. And so what I'm doing here is I'm saying I want to take and populate the slot values that I have for topping and crust, insert it into this message. And then we want to say that we have a fulfillment state of in progress because we're not done yet. And then we want to elicit for the particular wait stop slot that we created. And so when the user gets this prompt, the Lex bot will know that whatever the response is intended to be used to populate the wait stop slot. So if cooking status is in session attributes, then we know that we've already started cooking it. And then we can continue with just decrementing each of these rounds left to kind of progress. And then we keep eliciting this wait stop slot each time. And then this time around, I'm just using a helper method that's essentially doing that same thing of creating the message for you. But if you say that you, for wait stop, you don't want to continue and you say stop, that's essentially ending the interaction. And so I've set it up so that we first say what your pizza is, and then based on the number of rounds left, we can specify what the result is. So since there was 2 rounds left on the first one, it was completely uncooked. If we had waited just 1 round, it would be a little undercooked, but you'll survive. We saw the cooked perfection. And then if you keep going, there's no reason why you can't keep waiting. Your pizza will burn and set fire to the pizza shop. At that point, we go ahead and clear the session attributes so that any future requests won't have that mixed up data. And then we can go ahead and create a fulfilled intent, a response to share that this message that we provided. All right, so that basically concludes the demo of it. As part of the AutoNation challenge, we mentioned that we wanted an SMS chatbot. So you do get bonus points if you are doing our challenge and it integrates with some sort of SMS service. I wanted to provide just some additional information to let you know what you can kind of use to help you build that. In addition, AWS, Amazon Lex provides lots of ways for you to chat or interact with chat platforms as well. So for SMS integration, Amazon has something called Amazon Pinpoint. Honestly, I probably wouldn't recommend it. It costs money and you have to provision numbers for $2 a month, and that's not part of free tier. So I strongly recommend that if you're doing SMS integration, just use Twilio. Normally, they provide a free trial balance worth $15.50, but after the opening ceremony, found out that ShellHacks is providing, there's promos for specifically ShellHacks. So you can use this promo code for $25. And essentially, it can be set up in minutes to interact with your bot that you create. If you're just using the developer stuff and it's not live yet, it will add a signature on all the text messages saying sent from Twilio, but that's not really a big deal. So after you create your Twilio account, it's very, very simple to set it up. Essentially, you're just providing the authentication token and account SID that Twilio gives you, and hit activate, and it will just work out of the box. But check out that tutorial if you're interested in doing that. For Slack chat integration, Lex makes it very easy to do Slack and Facebook Messenger, very similar to the way that Twilio has hooks in for Amazon Lex. And then since this is using Discord, there's plenty of ways to do it with Discord as well. It is similar to the way that the Amazon Pinpoint setup is working. Essentially, you would create another Lambda that kind of delegates to it. So I've provided some additional resource links here. What I can do is I can share out this deck after the presentation. If you're interested, feel free to reach out in the AutoNation channel in Discord. And then I've also provided all the code from this talk over here. So we've got Java, Python, that pizza demo I mentioned. And then within here, the Lex v2 Lambda demo Python .zip. That's just the Lambda function that you can upload. And then there's the sample Lex v2 bot export JSON.zip that allows you to kind of import the bot directly without having to set up the intent and stuff like that if you want. In Pizza Demo as well, I provided the Lex bot itself that you can import into Lex. So any questions? Also, we're hiring, and if you use this QR code, it goes straight to the same link here. Let's see, where'd the tab go? Oh.
Hey, Derek, we have some questions in the chat.
Okay. Let me find the chat. Okay, perfect. Let me switch over to the camera.
If it's easier, I can either paste them somewhere or you can just go down the list. I have them for you.
All right. Is it in the Q&A section or what do we?
It's just in chat.
Chat? Okay. All right. You want to moderate for me? There's a lot going on here.
So Yuvia has asked, and I apologize if that's not pronounced correctly, how does it handle input that it is not trained for?
So in general, if you've trained some, it's pretty good at finding a match automatically. However, if it can't detect anything, what it'll do is it'll go and use that fallback intent. And basically, you can use that intent to tell the user, hey, I don't know what to do, you know, try something else. But in general, you can just, if you run into that situation, you can just add more training data. But it really doesn't need very much. I provided only a couple of utterances, and it was able to pick up a lot.
Yeah, and I'm going to skip one question because this one's related also from Yuvia. Do you do any sort of research to try to predict how a user will respond to then be able to write these scenarios out?
So yes and no. A lot of it initially is, just kind of thinking it through and just thinking about, you know, what a real person would do. But then once you have kind of a bot out there in the wild, you can start tracking what people are actually saying, and then kind of build additional stuff intent-wise and utterance-wise to kind of match what you actually see people saying. Does that make sense?
Yeah, to add on to that, what we typically do is we kind of send around a questionnaire to our team just to say, hey, how would you ask for this? We populate it with those, and then we're logging all of this, and we will use customer feedback to actually add in additional values. So we're looking at those logs. I'm going to jump to Corey. Is it possible to categorize the color by hex values?
So you can probably write a code hook to be able to do that. A user wouldn't be able to detect or be able to talk. They generally wouldn't talk in hex values. There is a built-in slot type for alphanumeric values by Amazon if you wanted to include that. But then at that point, essentially, you could probably write a function where you would take in a color. It would have some sort of default like hex value, and then you can compare it against the RGB to see what's closest to kind of map it that way. If you want help with doing something like that, I can talk to you after this, just in private. Just reach out to me on Discord.
Yeah, great. And as a follow-up to the last on how we're doing sample phrasing and stuff, the confidence score that Derek spoke about is super helpful in some of these, in addition to using sentiment analysis to determine how the interactions went. Jumping to another question from Noah, just wondering, are the values case sensitive for the bot or no?
So the values for, is it the utterances or the slots, or so basically if you have a slot, it will map it to whatever whatever you provide, and if you have that uppercase, then it will map that to something uppercase in your Lambda. So you would have to kind of deal with that. If you don't want it to be case sensitive, you could just compare things using, ignore case kind of, or you can make everything lowercase or uppercase.
And just to add on to that, Derek, is it case sensitive for the utterances?
No.
Okay, good. Another question from Yuvia. Do you just get the functionality, or do you also get the interface?
So the interface, you can either use the Lex console for testing purposes, or if you integrate with, say, Twilio, that will provide all the interface for you, because basically it just hooks in directly with them and it goes straight to your phone when you're doing SMS. You don't have to build additional interfaces for that. If you want to, Lex does provide APIs, so then you can create your own kind of man in the middle to kind of delegate that out to Lex, or trigger things if you have some other mechanism you want to use. And that's provided, information on that is provided in the documentation. I provided in the extra resources links.
Yeah, there was a question to post your GitHub. I see somebody found it. We will also repost that link in the AutoNation channel on Discord. And then there was a question on how do we connect it to a website?
So depending on which direction you want, essentially that would go back to using the APIs that they provide. It's known as their Lex Runtime API. And basically your website would make a call to this Lex Runtime API, and you can either put that in its own Lambda, or if you have your own server that you're hosting, you can call it directly via that. Is there any other questions, Bobby?
That was the last one for now. Does anybody in the chat have any other questions for Derek? None yet. If you think of one, Derek's going to hang out for a while. He'll be in the mentor channel on Discord as well as the AutoNation. So feel free to stop by and ask him a question.
I believe this video is being recorded right now. So yes. Yeah, let me get the presentation available to share, and that'll be available within the AutoNation channel. The Lex v2 docs on the slide. Yes. It will be posted on the AutoNation Discord channel. Just give me a few minutes to get that uploaded. But yeah, that's where you will find it. And yeah, feel free to reach out to me anytime during the hackathon. I'm available on Discord. Derek Lomibao. I guess you can see that in my name.
Great, thanks, Derek. Yeah, if anybody has any other questions, feel free to swing by Discord. We'll be hanging out for a while. Thank you very much. Good job, Derek.
Thanks. Yeah, let me go ahead and upload that. And I'll monitor the chat as well. Okay. Let's see. Okay. Let's go ahead and upload that.
If anyone has any questions about AutoNation, about Derek's career, or anything along those lines as well, feel free to ask those. It doesn't have to be just about that session. He'll be hanging out to answer any questions you have.
All right, everyone. I have uploaded the presentation, and it is available within the AutoNation Discord channel. So feel free to download it, or here I'll also paste it in the chat. All right. Thanks, everyone, for your time.